Hi everyone. In this video, we're going to talk about the domain and range of relations. So this is a general concept that covers all relations, even those that are not functions. But we're likely going to focus mainly on functions because functions are very powerful in the world. But keep in mind that this can apply to any relation, even if it's not a function. So there's going to be a lot in this video. This is a very abstract concept with lots of notation. So be patient with your learning. It's going to take some time to wrap your head around what we're talking about. So I'm just going to start. And as a reminder, if you need help, please don't hesitate to reach out. So the domain is the set of all x values of any relation or a function more specifically, but it's just all the x values that exist in that relationship between x and y. The range is the same idea, but it's all the y values of a relation. These two concepts are easiest to see and understand them graphically. So I just gave a very bad, actually, example here of a graph because it's really hard to hand draw graphs, that are nice and neat and easy to read. So there's my very poorly drawn just example of a function, a general function. So let's talk about what the domain means, and I'm going to use some new notation here. It's called interval notation. I'm going to do this problem first, and then I'll give you some notes about how to use interval notation. So this is different than function notation. So the domain is all the x values. So what you're looking at is, think about all the points on this graph. There's an infinite number of them. And then think about all the x coordinate values of every point on that graph. And if you could list out all of those x coordinate values, that would be the domain. Now, obviously, that's why we have some notation to help us because there's an infinite amount of x values on this graph. So that would be a lot to list out by hand. It would literally take me forever since there's an infinite number. Like, I don't mean that figuratively. I literally sit here until the end of time listing out all the x values that has points on this graph. So I'm going to show you down here, I'm going to use some quick hand notes that help me figure out the domain. So scan your eye left to right because that's the x, this is the x-axis, right? Let me move this graph over a little bit so I have some room for the y. Okay, so this is the x-axis. Okay, so this graph keeps going forever to the left and up. So it keeps going like that, that's that arrow. And it stops here on the right. So the furthest left that I can go in terms of the x values is negative infinity. It is every single x value in the leftward direction would have a point on this graph. So the domain, if I just use it as a number line, it would look like this. It would go all the way to the left forever. And all the values in between negative infinity all the way up to this x value right here, stopping right there, that would be the domain, okay, because there's a point right there. Now, that is an open circle. It's not a filled in. It's not a shaded circle. So that means there's not actually a point there. So the domain of this entire function is every number that is less than 4. Every number that's less than 4. So we can say that, I'm going to say that 3 different ways. I'm going to say that in English, then I'm going to use inequality notation, and then I will use interval notation. Okay, so the domain is every number less than 4, not less than or equal to, because that's not a filled in circle. So that's key. It's just every number less than 4. And another way to say that is you could just write it x is less than 4. This is called inequality notation because that symbol is an inequality symbol. Okay, and then a final way to write it, which is where we're stacking on layers of complexity into this lesson, is using interval notation. Interval notation is going to look like this. You're going to put a parenthesis and then a negative infinity sign. So a side where it's 8, that's an infinity sign. All the way up to positive 4, and then you're going to put a parenthesis. Now the reason for the parentheses are because it's not less than or equal to. If it said less than or equal to, then we would use a square bracket like that. And I'm going to write these notes for you in a minute. But I just wanted you to take note. We're using parentheses deliberately because you can never equal infinity or negative infinity. It's not a number, so you can't be exactly equal to it. And in this case, you can't equal positive 4 because this is not a filled in circle. So open circle gets parentheses. If it were a closed circle, it would get a bracket, a square bracket. Okay, so that's the domain. And again, this is called interval notation. So I want you to be comfortable with all three. I want you to be comfortable explaining in English what is the domain, using inequality notation, and using interval notation. Okay, again, that was just the domain. Let's look at the range. So the range is the same concept, but now you're scanning up and down, looking at all the y values. And you're think about all the points on this graph. Like if I just start plotting points, think about all the points on this graph. And if you were to list out, like I'm just plotting random points. If you were to list out all of the points, like this is -2, 4, and then this is -1, 3, and then this is 3, -3. There's literally an infinite number of points. And then you were to ask yourself, what are all the y values for every single point on this graph? And could you list them as a set? That would be the range. The domain is the same thing, but it's all the x values of every single point. It's the collection of all the x coordinate values of all the points on this function. Okay, so the easiest way to do that, conceptually, is to scan your eye and see, like, do you see how this is a continuous graph? It hits every single y value that I'm currently touching, except for down here. Down here it stops. It doesn't fall lower than the y value of -5. So that means that's the lowest possible value in the range. So the lowest possible value, and it's a filled in circle this time because there is a point there. The lowest value is -5, and then the range keeps going all the way up. It hits every single one of those numbers. It hits the number -3 right there. It hits the number -2 there. It hits -1 there and there. It doesn't matter if it hits it in more than one spot. You just have to count it once. It hits it at 0. It hits it at 4. It hits it at 2.5, 1.33333. All of those values that I'm listing, they're all part of the range because you can find a point on this graph that has those values as their y coordinates. That's a lot. That's a lot to internalize, how I just explained that. So give yourself time, let that idea sit with you. You are trying to list out all the possible y values of every single point on this graph. And because that's difficult to do, because the answer is that there's an infinite number of y values, that's why we use notation like this to help us. So the smallest value here is -5. And because that arrow on the left goes up forever, the highest value is positive infinity because it keeps going up forever. So here you go. The domain in English is all numbers greater than or equal to -5, because that's the lowest value there. It's everything greater than or equal to that going up. Put this up here so you can see. Now, if you want to use inequality notation, you could say that's the same thing as saying x is greater than or equal to -5. Not x, that's a mistake because we're talking about the range. So we should call that y. There we go. Yeah, what I meant there is y is greater than or equal to -5. And then if you want to use this interval notation, now you're going to see an example of the closed bracket. So the smallest value comes with a closed bracket, and then you put -5, comma, all the way up to the largest value, which in this case is positive infinity. Always infinities will get a parenthesis because you cannot equal infinity. Okay. So I told you I would give you some notes. So I put here open circle gets parentheses. So we're going to put down here closed circle or shaded in circle, however you want to explain that. Closed or filled in circle gets brackets. And when you use this interval notation, you could have things that have A comma B with both parentheses, like we saw here. I'm just writing that in general. Or you could have things that are like A comma B that are both brackets, which we didn't see in either of this cases. Or you could have a bracket on A and then a parentheses on B, or a parentheses on A and then a bracket on B, right? So it could be any one of those cases. So don't feel like if you use a parenthesis, the other one has to be a parenthesis. It's not like that. It's thinking about what is this specific number, what's the lowest y value in the range, and is it included or is it not included, in which case it should have a parenthesis. Okay, so again, there was a lot. This was a lot jam-packed into one fairly short video. This is just one example. I'm going to erase this and put up one more example. It's a little bit more complicated, where you will see a jump in the graph and how you write that using this interval notation if you see a jump like that. So let me erase this, and we'll just put a new graph up here. Okay, so let's say you have something that looks like this, where that's a straight line. Doesn't look very straight, doesn't look solid. There we go. Okay, up to -1. And then we'll do this like that. Okay, so we'll call that 1. We'll call this 2, 3, 4, something like that. This will be -1, and then down here is -2. This point here is 2, and then we'll call that point 4. Okay, so again, these are hand-drawn, so sorry, they're kind of poor. They're very poor quality. But it gets the point across. So let's look at the domain. So the domain of this graph, as you can see, it has a jump in it. So the domain starts at -infinity. Actually, you know what? Why don't we close this circle here so that we have a different example. So we'll close this circle here. And then, you know what? We'll put another open circle here because why not? So right here at 4. Okay, there. So now it's not, the graph doesn't go on forever in both directions. So it's good to have examples of when the graph is contained and stops. And then, like, it's good to have the other example where the graph does keep going, like we just did. So now that I've kind of modified this, let me give myself room. The domain is going to be, I need more x values here. So -1, -2, -3, we'll call that. Okay, so the domain, it goes from -3 up to -1 and stops with an open circle. So I'm just drawing the domain down here, what I know is the domain. The domain is all the x values that have points on this graph. And right now, all of those x values, they have points on this graph. Then there's a big jump, and then you pick up at 1, filled in, so there's a point there. And then it keeps going up until, I need to label this last point as 5, up until 5. And it's an open circle at 5, right? Because there's an open circle there. So it looks like that. These should all be aligned. So now that we've kind of drawn it on a one-dimensional number line, so it's like you're taking a two-dimensional graph and you're saying what is the x dimension that it covers, and then separately for the range, what's the y dimension that it covers. That's a similar idea to what you're doing. So this, if you want to use interval notation, is -3, comma, -1, bracket on -3 because there's a filled in circle, parentheses on -1 because it's an open circle. Then when you have a jump, the notation is going to be union. So that's just it looks like a U, like a capital U. So you're saying join this segment with this segment, starting at +1 and going up until 5 with a parenthesis again because there's an open circle here, bracket on the 1 because there's a closed circle here. That is the domain. That's using interval notation. You could also do this using inequalities. It's going to look a little complicated, a lot complicated, I should say. So the inequality will look like this. X is greater than or equal to -3, but less than -1. That's the first part. And then when we have inequalities, we just say and. So we just write the word and. X is less than or equal to 1, and then less than 5. So there you go. There are both notations for you. So you have the interval notation and you have the inequality. Again, it's good to know both. Why don't you pause your video now and see if you can find the range of this function using both sets of notation. All right, so the range, it looks like the lowest y value is -2. According to my very poorly drawn graph here, I'm just going to assume that this is that point right there. And then all of these y values have points up until 4. All of them have points up until 4. And there is a point at 4 as well. It's not here, but there are points where y equals 4. And you just need 1 point for that number to count as part of your range. So here is a point, for example, -2, 4. That is an actual point on this graph. And so 4 should be included in the range. In other words, don't just use the point that you see all the way on the right or only the one you see all the way on the left. That's not how you figure out the range. That is how you figure out the domain, but not for the range. The range is the lowest point up to the highest point, and you just need 1 actual point on there to count. Okay, and all of these are all points right here, right? So all of them, I can't sit there and fill them all in, but every single one of them. That's why the range is all of these numbers between -2 up to +4. So there is no jump in the range, actually. So even though there's a jump in the graph, that only affects the domain in this particular example. So the range would be, always start with the lowest value. It's going to be, here, I'll put it here, -2, 4, both with brackets because they both have points at those exact numbers. If you wanted to use interval, that's interval notation. If you wanted to use inequalities, then you could write -2 is less than or equal to y, which is less than or equal to 4. And there you go. Now you have all sets of notation. You have lots of different examples on here as well, just in the 2 examples that we covered. Okay, so again, that was a lot. So sometimes it helps to see this in a Desmos activity where the computer helps you to shade certain parts of the graph so that your eye is looking at the right thing. So what you're going to do next, and I'm going to let you do this on your own, so I won't have a video where I do this with you, is you're going to log on to Desmos and find the activity called Domain and Range Introduction. And you're just going to work through this on your own, but what I wanted to show you was if you do these right, so you can check your own work, if you do these right, this shaded part should fall right where the whole graph is. So right now I have this wrong. So if I change this, like for instance, if I change this to 8, the shading is wrong because the graph stops right here. So I should figure out how to make the graph stop right there. And also if I put, let's say I put 3, then this shading is wrong too because the graph keeps going a little further than that. So the correct answer in this specific case should be 4, and then you can see it would fall right on top of the function. And so this type of visualization, that's what I picture in my head when I'm looking for the domain. There's a couple, most of this activity focuses on the domain, but when you get to the last few slides, some of these think about the range, and that's why you'll see these are Y now. So all the previous activities, they're all labeled X. These ones are going to be labeled as Y, and see how they're helping you to train your eye to look vertically up and down. So this is a nice activity because it trains your eye to make sure that you're looking at the correct thing, either shading this idea of like left and right for the domain, or when you see the range, when you get to these questions, making sure that you're scanning your eye up and down for the range. But in both scenarios, you're still doing the same thing. So in every time you're trying to find the domain or range, what you need to be thinking about is the domain is the set of all X values that you would see on the graph. The range is the set of all Y values. And there are 2 different ways that you could represent those sets. You could use integral notation, which is this new complicated notation we sort of introduced. Although once you get used to it, many students find that it's actually easier. And we've learned inequality notation, which also looks a little bit complicated when you have breaks and when you have things, you know, sectioned off from one endpoint to another. The last way that you could describe the answer to these questions is in English. So if you're taking an assessment in my class and you're not quite sure of how to write the notation and you're getting, you know, confused with just the notation part of it, then write the domain in English the way we did the first example. Just put it's all the X values in between -3 and -1 and all the X values in between 1 and 5. That is the same thing as what we just wrote here using mathematical notation. So feel free to put those in your notes. That way you can check to make sure that the notation you're saying here is really what you mean to be saying when you explain what that means in English. As usual, if you have any questions, don't hesitate to reach out. Lastly, what we're going to do next is talk about the practical domain and range, which focus on thinking about the appropriate domain when you're modeling a real-world problem. So again, this whole lesson, we focused on abstract math. There was no word problem here. This was not associated with a real-world context. In the next lesson, we are going to do things in a real-world context and think about what kind of domain and what kind of range would make sense in a very real way if we were modeling something in the real world.